Great afternoon, students. Today we are going to discuss next chapter, electric potential. The name of chapter is electric potential, and we are going to discuss first topic, electric potential difference. So, students, what is electric potential difference? The concept of electric potential difference you have discussed in the 10th standard. So what is electric potential difference? Electric potential difference between 2 points. Whenever we discuss the concept of electric potential difference, it is between 2 points. Electric potential difference between 2 points in electric field is defined as amount of work done per unit positive test charge in moving it from one point to other point without acceleration against the electrostatic force due to electric field. Electric potential difference between 2 points in electric field is defined as amount of work done per unit positive test charge in moving it from one point to other point without acceleration against the electrostatic force due to electric field. Clear? You can just check from here. Electric potential difference between electric field is defined as amount of work done per unit positive test charge in moving it from one point to other point without acceleration against electrostatic force due to electric field. Electric potential difference. Expression for electric potential difference. Suppose that we have a point charge plus Q is present at the point O. We have a point charge plus Q is present at the point O. Now, this point charge will produce electric field. This point charge will produce electric field, and A and B are any 2 points. A point charge plus Q is present at the point O. This point charge will produce its electric field, and these points A and B are present in the electric field produced by the point charge plus Q. Clear? So in other words, we can say that here A and B are any 2 points which are present in the electric field produced by point charge plus Q. Clear? And what is the definition? Definition is amount of work done in bringing the unit positive test charge from one point to another point. So we have to plot the test charge from this point to this point against the electrostatic force due to electric field. Clear? So from figure we see that RA is the distance of point A from point charge plus Q. RB is the distance of point B from this plus charge, this point charge plus Q. We see from the diagram here. So let us consider a point charge plus Q is present at point O. Let A and B be any 2 points present in the electric field of point charge plus Q. RA distance of point A from plus Q charge, that is from O. Similarly, point B from plus Q charge, that is from point here, from point here. So what definition? You can say that VA, what is VA? Electric potential at point A. VB, electric potential at point B. So what definition? So by definition, electric potential difference is defined as amount of work done per unit positive test charge. So by definition, VB minus VA is equal to WAB by Q naught. Potential of B minus potential of A is equal to work done per unit positive test charge. Clear? By Q naught is a VB minus VA. This is equation number 1. This point charge plus Q is present at the point O, and let P be any point. Here P be any point at a distance R, and P be any point at a distance R from point charge plus Q. From here we see that P be any point in the electric field of this point charge plus Q, and this point P is present at a distance small r from the center O. Clear? As we see from here, P due to point charge plus Q is given as, so what electric field? E is equal 1 upon 4 pi epsilon naught Q upon R square. This is the electric field produced by point charge plus Q at a distance small r at the point P. Clear? This is equation number 2. Clear? So electric field at point P due to this plus Q charge is given as E is equal to 1 by 4 pi epsilon Q by R square, and here R is the distance of point P from this charge. Yeah, you can say from point O. Okay. Now we have to brought this test charge from point A to point B. Now suppose that whenever we brought this test charge from point A to point B, and during its journey the test charge is present at point P. This test charge is present at the point P. Whenever we brought this test charge from this point to this point, and suppose at an instant the test charge is present at the point P, so force experienced by this test charge, Q naught from point and point is at point P is given as force experienced by this test charge at point P in the electric field of this point charge is given as F is equal to Q naught E. And this formula came E is equal to F by Q naught, and from here F is equal to Q naught E. This is the force experienced by test charge in the electric field produced by point charge plus Q. And this clear? Now suppose that this is here. This is the force experienced. F is equal to Q naught E. This is the force experienced. Now suppose that this test charge move through a small displacement. Now suppose that this test charge is moved from point P to point Q through a small displacement dr. Now suppose that this test charge is moved from point P to point Q through a small displacement dr. This test charge is moving from this point to this point through a small displacement dr. So small amount of work done in moving the test charge is given as moving the test charge from point P to point Q is given as small amount of done to force into displacement. F is a force, here is the displacement, small displacement. And by using 3, what is the value of force here? Q naught E. dW is Q naught E into dr. And from here we see that naught E and displacement dr are in opposite directions. F is equal to Q naught E and dr are in opposite directions. So dW is Q naught E into dr cos 180 degrees. Clear? Force into displacement. What is the value of force? Q naught E into dr. Q naught E dr cos 180 degree. Here angle is taken 180 degree because this force and displacement are in opposite direction. So we have taken angle 180 degrees. dW is equal to Q naught E dr, and what is the value of cos 180? Minus 1. This dW is minus Q naught E dr. Now using equation 2, E is equal to 1 by 4 pi epsilon naught Q by r square, and putting this value, the value of E in these equations, we get small amount of work done is equal to minus Q naught. What is the value of E? 1 upon 4 by epsilon naught. 1 upon 4 by epsilon naught Q upon r square into dr. This is it. Q naught into 1 upon 4 pi epsilon naught Q upon half square into dr. dw is equal to minus 1 upon 4 pi epsilon naught Q naught upon r square into dr, and this is equation number 4. Clear? Work done in moving the test charge from this point to this point, from point P to point Q. Now total amount of work done in moving the test charge from point A to point B is given by integrating equation number 4. So total amount of work done, in moving test charge from point A to point B is given as WAV equal to from point A to point B dW. Using equation 4, what is the value of dW? Minus 1 upon 4 pi epsilon naught Q naught upon r square into dl, and from RA to B. We had brought this charge from this point to this point. Distance at this point RA, distance at this point RB. So integrating epsilon naught Q naught dr r square, limit distance from A to distance from B. This is the work done in moving the test charge from point A to point B. 1 upon 4 pi epsilon naught Q naught. This is minus sign here. It can be written as dr. This is the formula. X is power n dx is equal to x n plus 1 upon n plus 1. So simplifying, we get WAV to minus 1 upon 4 pi epsilon naught Q naught, using like this n plus 1. Here minus 2 is on the base of n. Minus 2 plus 1, minus 2 plus 1 by making use of this formula. Limit RA RB WAB minus 1 by 4 pi epsilon naught Q naught R minus 1 minus 1 RA RB can be written as WAB. This is Q naught present here, it comes here upon Q naught minus 1 upon 4 pi epsilon naught Q minus 1 upon R, limit from RA to RB. Clear? Minus minus plus 1 upon 4 pi epsilon naught Q minus minus plus 1 upon R RA RB. So by applying the limits here, Q naught is equal 1 upon 4 pi epsilon naught Q, upper limit minus lower limit, 1 upon RB minus 1 upon RA, and this is equation number 5. Now comparing equation 1 and 5, comparing equation 1 and What is equation number 1? This was equation number 1, WAB by Q naught is equal to BV minus VA. It was equation number 1. So comparing these equations 1 and 5, we get VV minus VA. As we can say that left hand side of both equations are the same. From here, VA is equal to 1 upon 4 by epsilon naught Q 1 upon RB minus 1 upon RA. So this was our result for the electric potential difference. This was our result for the electric potential difference. And electric potential difference is a scalar quantity. So what was the electric potential difference? Electric potential difference between 2 points A and B is defined as amount of work done in moving the unit positive test charge from this point to this point against the electrostatic force without acceleration in the electric field. Clear? Thank you. Have a nice day. Units of electric potential difference. Unit of electric potential difference as we know from the definition of electric potential difference, definition of electric potential difference, VV minus VA is equal to WV by Q naught. This was equation number 1. So from here, as we know that unit of work is joule, unit of charge coulomb, so from 1 VV minus VA WAB by Q naught, so this will become joule charge coulomb, it will become joule per coulomb, and this is known as the volt. This is known as the volt. Joule per coulomb, this is known as the volt. Now how we can define 1 volt? Define 1 volt. Define 1 volt. Now if WAV is 1 joule, Q naught is 1 coulomb, then VV minus VA is 1 joule per coulomb, yeah, 1 volt. So electric potential difference between 2 points A and B is said to be 1 volt if 1 joule of work is done in moving a test charge of 1 coulomb from one point to other point against the electrostatic force in the electric field without acceleration. Clear? So it can be written as electric potential difference is said to be 1 volt if 1 joule of work is done in moving a test charge of 1 coulomb from this point to this point without acceleration against the electrostatic force due to electric field. It was all about the 1 volt. Now we discuss the dimensional formula of electric potential difference. Dimensional formula. dimensional formula. Dimensional formula. VB minus VA WB upon Q naught. What is the dimensional formula for the work? For work M L2 P minus 2 and dimensional formula for charge AP, so it can be written as M L2 T minus 3 A minus 1. So dimensional formula of electric potential difference is given as work upon charge. Dimensional formula for work ML2 T minus 2 for charge AP. So it is written as ML2 T minus 3 A minus 1. Thank you. Have a nice day.